Hey everyone, welcome back to my channel, where we dive into the world of coding and explore solutions to some of the toughest problems out there. Today, we're going to tackle a LeetCode problem that's sure to put your skills to the test. It's called block placement queries, and it's a hard one. So buckle up, we'll break it down, go through the intuition, and then walk through the code step by step. So, let's get started. The problem is all about placing blocks of certain sizes at specific positions on a line, without intersecting with obstacles. We're given a list of queries, where each query is either an obstacle or a block placement. Our job is to determine if the block can be placed at the given position, without overlapping with any obstacles. So, what's the key insight here? Well, imagine you're trying to park a car on a busy street. You need to find a gap between the other cars that's big enough to fit your car. That's basically what we're doing here. We're maintaining a sorted set of obstacle positions. And then for each query, we're checking if there's a gap between obstacles that can fit our block. It's all about finding the right spot to place the block, just like finding a parking spot. Now, let's walk through the problem step by step. We start by initializing an empty set to store the obstacle positions, and an empty vector to store the results of each query. Then, we iterate over each query in the input list. If the query is an obstacle, we simply add its position to the set. But if it's a block placement, we need to check if there's a gap between obstacles that can fit our block. We do this by iterating over the sorted set of obstacles, and checking if the gap between each obstacle and the next one is big enough to fit our block. Okay, so let's take a look at the code. We start by defining a class called solution, with a method called getResults. This method takes a vector of queries as input, and returns a vector of Boolean values representing the results of each query. We initialize an empty set called obstacles, and an empty vector called results. Then, we iterate over each query in the input list. If the query type is 1, we insert the obstacle position into the obstacles set. If the query type is 2, we iterate over the sorted obstacles set, and check if there's a gap between obstacles that can fit our block. We use a variable called canPlace to keep track of whether the block can be placed or not. We also use a variable called previous to keep track of the previous obstacle position. We iterate over the obstacles set, and for each obstacle, we check if the gap between the previous obstacle and the current one is big enough to fit our block. If it's not, we set canPlace to false, and break out of the loop. Finally, we add the result of the query to the results vector, and return it. So, what's the time and space complexity of this solution? The time complexity is n*m, where n is the number of queries, and m is the number of obstacles. This is because in the worst case, we're iterating over all obstacles for each query. The space complexity is n, where n is the number of obstacles, because we're storing all obstacle positions in the obstacles set. And that's it for today's problem. I hope you guys enjoyed it and learned something new. Block placement queries can be tricky, but with the right intuition and approach, they can be solved efficiently. If you liked this video, be sure to like it, subscribe, and comment your approach below. Let's keep coding, and see you in the next video.